Hi guys, welcome to our lesson today on multiplying polynomials. Our goal for today is for you to be able to multiply all different types of polynomials. So we're going to start with a warm-up, and then we're going to multiply some binomials together. We're going to square binomials. We're going to multiply different kinds of polynomials. And then we're going to finish up with some applications or word problems using what we just learned. All right? So here's where we're going to start with our warm-up. So pause the video now for a minute, do these 7 warm-up problems, and then when you come back, you can. All right, so here's your answers to that warm-up. So take a minute, you can pause the video again and check these. In number 1, you're adding 2 polynomials, and your answer ends up being a quadratic trinomial. Quadratic because the biggest exponent is a 2. Trinomial because you have 3 terms. Number 2, you're subtracting 2 polynomials, so don't forget to distribute that negative right here. And your answer ends up being a linear binomial. Number 3, here you're multiplying. If you remember, think back, this is called the distributive property. And number 4, we're kind of going back to using our rules of exponents. This is our power to power rule. So remember, you take the 2 to the second power, 2 squared is 4, and then when you raise the power to power, you multiply the exponents. And then numbers 5, 6, and 7, you guys did some problems like that yesterday, where you had to find 2 numbers that multiply to a certain number and then add to another number. And you're going to see why we're working on these in the next couple of days. So now that we have finished up the warm-up, let's get into the lesson. So our agenda for today, again, our goal for today is to multiply polynomials, right? So here's our steps for multiplying polynomials. You multiply each term in the first polynomial by every other term in the other polynomial. And then ultimately you combine like terms, right? So for example, I'm going to take the first polynomial, which is this, 3n plus 2, and multiply each term in that polynomial by every other term in the other polynomial. So this is the other polynomial, okay? So I'm going to take this 3n, and I'm going to multiply 3n times n, and then 3n times 3, kind of like distributive property. 3n times n is 3n squared. 3n times 3, 9n, right? Then I'm going to take this 2, and same thing, multiply it by every term in the other polynomial. So 2 times n is 2n, 2 times 3 is 6. So now I multiplied, I did step 1. But now if you look at what you have here, this is not totally simplified. Now we're going to go on to step 2 up above, combine like terms. So my like terms here are the 9n and the 2n. So I'm going to combine those like terms and get my final answer, 3n squared plus 11n plus 6. All right? Let's try it one more time. So here's number 2. We're going to take this n and multiply it by every term in the other polynomial. N times 2n, 2n squared. N times negative 2, negative 2n. And now I'm going to take the second term in that first polynomial, that negative 1, and multiply it by every term in the other polynomial. So negative 1 times 2n, negative 2n, negative 1 times negative 2 plus 2. So again, I'm done step 1. I've multiplied. Now I need to combine my like terms. Here's my like terms, the negative 2n and the negative 2n. So I'm going to make sure I write my answer in descending order with the biggest exponent first, 2n squared. And then negative 2n minus 2n is negative 4n plus 2. Make sense? All right, you can pause the video now and then try the next 2 problems. All right, so check those 2 problems. You're going to notice in number 3 here, problem number 3, something weird happened. These 2 terms Negative 6x plus 6x, when you add them together, they cancel out. They give you 0. So in your final answer, you only have a binomial. You only have 2 terms left, right? And that's okay. So down below, sometimes when we multiply 2 binomials, we call this the FOIL method. And FOIL stands for first, O is outside, I is inside, and L is last. All right? So what I mean by that is if you go back and look at like number 2, for example, you can see everything I did in red. I used that N, this first term right here, and I multiplied N times 2N, right? Or in other words, I multiplied the first 2 terms together in the binomial, N and 2N. And then the outside terms would be considered N and this negative 2 here. Those are the outside terms. Next, I went to the negative 1. I can think of the negative 1 and the 2N as being like the inside terms. They're kind of like right next to each other. And then the last terms, this is getting confusing. Let me get rid of some of these arrows. So the last terms would be the negative 1 and the negative 2. They're the last terms. So first, outsides, insides, last. All right, and we're going to kind of use that FOIL. We'll kind of use that method as we multiply binomials. So set number 2, we're going to simplify by multiplying. When we square something, when we square a polynomial, whenever we square something, we multiply it by itself, right? So for example, number 5 here, x minus 5 squared, that really means x minus 5 times x minus 5. You got to write that out twice, okay? I multiply by itself, and when I multiply by itself, I follow the FOIL method. First, outside, inside, last, okay? And really, the FOIL method is just kind of like an easier way to remember how to do this, to multiply each term in the first polynomial by every other term in the other polynomial, all right? So here we go, ready? First, outsides, insides, last. So first would be x and x. So x times x is x squared. Outsides, x times negative 5, negative 5x. Insides, that would be this negative 5 here and this x here. They're on the inside, so negative 5x. And last, the last terms would be negative 5 and negative 5. So negative 5 times negative 5 is a positive 25. So now I did all my multiplications. Now I still have to combine my like terms. My like terms here are the negative 5x and the negative 5x. Again, make sure my answer is written in descending order. So I'm going to start with the x squared. Negative 5x minus 5x is negative 10x plus 25. There's my final answer. All right, so you can pause the video and try number 6 on your own, or you can follow along with me. I'm going to go through it real fast. Again, when I square a binomial, I have to write it out twice. When I square anything, I write it out twice. And then I got to multiply using the FOIL method. First, outsides, insides, last. So p times p squared. Outsides are going to be this p and this 6p. Insides, this 6 and this p. So again, I have 6p. Last terms are going to be the 6 and the 6. So 6 times 6 is 36. Combine my like terms. Final answer should be this right here. P squared plus 12p plus 36. Right? All right, guys. So now at this point, I want you to pause the video and I want you to try set 3. Simplify by multiplying. Same thing. You're using the FOIL method, all right? And then when you are done, you can unpause it and check your answer. All right, welcome back. Check your answers 7 through 10. And hopefully you noticed that something happened here. When I multiplied all of the middle terms, all of the like terms, when I added those, they all canceled out. So all of my answers, all of my 4 circled answers here are now binomials. I just have 2 terms, all right? Not only are these binomials, but they're also like a special kind of binomial, all right? You're going to notice that for each of these binomials, again, these my circled answers, I have b squared minus 25. 25 is a perfect square, right? I have m squared minus 9. 9 is a perfect square. 4 is a perfect square. 16 is a perfect square. 49, 1. They're all perfect squares. Do you notice that? A squared, z squared. So all of these terms are perfect squares. The other thing I want you to notice is that all of my answers are something minus something. B squared minus 25, m squared minus 9, 4a squared minus 16, 49z squared minus 1, right? So these are called, these solutions here are called difference of 2 squares. And I want you to notice that's what we can kind of notice about the answers. Now I want you to kind of look at the original problems, number 7, 8, 9, and 10. Those original problems are all sum and difference of 2 terms. So number 7, you have b plus 5, b minus 5. Number 8, m minus 3, m plus 3. Do you see how it's the same 2 terms? I just have a plus sign in the middle and then a minus sign in the middle. In other words, a sum and a difference of 2 terms. So when I multiply the sum and difference of 2 terms, my answer is always going to be what we call a difference of 2 squares. That's what I want you to jot down here. So when we multiply sum and difference of 2 terms, the answer is always a difference of 2 squares. All right, that's going to be really important. We're going to come back to that in a later lesson. So make sure you jot that down and try and remember that. All right, we're going to just kick it up a little bit. Of course, we're going to simplify by multiplying. You're going to notice in number 11 now, I have a binomial, x minus 2, and I'm multiplying it by a trinomial, x squared plus 2x plus 3. So now I can't FOIL. I don't really have like a first, an outside, an inside, and a last because I have this extra term here. You know, I have 3 terms in that second polynomial. So instead of kind of thinking about like using the FOIL method, we're just going to come up to our original steps here. Steps for multiplying polynomials right here. Step 1, multiply each term in the first polynomial by every other term in the other polynomial. So we're just going to kind of remember to do that, all right? Ready? Here we go. So I'm going to take this first term, x, and I'm going to multiply it by every term in the other polynomial. So x times x squared, whoops, x times x squared is x cubed. X times 2x is 2x squared. X times 3, 3x, right? Now I'm going to take this other term, this negative 2, and multiply it by every term in the other polynomial. So negative 2 times x squared is negative 2x squared. Negative 2 times 2x is negative 4x. And negative 2 times 3 is negative 6. So again, now I've done all my multiplication. Now I need to combine my like terms, all right? So if I combine my like terms, again, as I combine my like terms, I'm going to make sure that I'm putting my answer in descending order with the biggest exponent first. So I'm going to notice that my biggest exponent is this x to the third here. I'm going to jot that down first. So x to the third. The next biggest exponent is the x squareds, right? I have a positive 2x squared and a negative 2x squared. Let me get rid of this right here. So I'm going to combine them. Positive 2x squared minus 2x squared, they cancel out. Now that's not always going to happen, but in this case it does. They give me 0. I don't have any x squareds left. So now I'm going to go for my my x's. I have a positive 3x and a negative 4x. So positive 3x minus 4x is negative 1x, or just negative x. And then the only other term I have left is my constant here at the end, this negative 6. So now my final answer is x cubed minus x minus 6. All right, so take a minute, pause the video, see if you can try number 12, and then you can check it. If you want to kind of watch me go through another one again, I'll do that for you now. All right, so number 12. We're going to take the a squared and multiply it by every term in the other polynomial. So a squared times a is a cubed. A squared times 3 is 3a squared. Then we're going to take the second term, this negative 5a, and multiply it by every term in the other polynomial. So negative 5a times a is negative 5a squared. Negative 5a times 3 is negative 15a. And then we're going to take the last term in this first polynomial, which is 1, and multiply that by every other term. So 1 times a is a, 1 times 3 is 3. Now we're going to combine our like terms. Again, we're going to start with just the biggest exponent. So a to the third. I'll rewrite that down here, a to the third. Let me look at my a squareds. I have negative 3a squared, negative 5a, I'm sorry, positive 3a squared and negative 5a squared. I don't know why I keep doing this. So I get, when I combine them, I get negative 2a squared. And then let me go to my a's. Here's my a's. Negative 15a plus a, negative 14a. And then just my constant, this plus 3. There's my final answer. All right, so it's always kind of the same process, no matter how many terms you have in the polynomial. All right, last but not least, everyone's favorite, an application problem. So let's read this and go through this together. You're going to build a rectangular garden in your yard. You don't know how big you're going to make the garden, though. So you design it with these dimensions. The length is x plus 5. The width is x minus 2. So first thing we're going to do is draw a picture, label the sides of our garden. All right? So here's my garden. It's a rectangle. So the length, they tell me, is x plus 5. The width is x minus 2, right? Perfect. All right, so step 2, find the perimeter of your garden. Well, how do you find the perimeter of a rectangle? You add up all the sides, right? Well, the problem is we only have 2 sides, but I don't know why it keeps doing this. We only have 2 sides, but we know that if it's a rectangle, if this is x plus 5, the side opposite is x plus 5. If this is x minus 2, the side opposite is also x minus 2, right? So the perimeter of my garden, I can add up all the sides. It's x minus 2 plus x plus 5 plus x minus 2 plus another x plus 5. Now this goes back to your last lesson on adding polynomials. So if I add polynomials, I'm just going to add my like terms. Let me look for all my x's. I have an x, an x, an x, an x. So I have 4x, and then let me combine my constants here. I have negative 2 plus 5, which is 3. minus 2 is 1, plus 5 again is 6, right? So 4x plus 6. And they don't give me units. They don't tell me if this is measured in feet or inches or yards or whatever. So I'm just going to write units. This is driving me crazy. I don't know why I keep scrolling up. Sorry. So here's my answer for my perimeter, 4x plus 6 units. To find the area of a garden, the area of a rectangle, is base times height or length times width, right? So it's going to be x plus 5 times x minus 2. Ah, look at this. This is what we just learned how to do. We just learned how to multiply, right? So we're going to multiply. We're going to use, this is two binomials, so we're going to use FOIL. X times x is x squared. X times negative 2, that's our first. Sorry guys. X times negative 2 is negative 2x. Now my insides, 5 times x, 5x, and then my last, 5 times negative 2, negative 10. Now I gotta combine my like terms. Here's my like terms. So my final answer would be x squared plus 3x minus 10. Again, I don't know the units, but this is gonna be units squared because when it's in area and I'm multiplying, I need a squared units. Final answer. All right, guys, thanks for listening and paying attention. Good job with multiplying.